This is the ECON315 Guided Study Group Session Lesson 5 Extra Practice. So the problems today, some of them have to do with equilibrium, which we've been doing, but they require a little more in-depth thinking. And then the first problem is a little bit bigger. It has a table that we'll go over, but I think they're all pretty manageable. Nothing too difficult from what we've done so far this semester. So I'm going to get started right away and look at question 1. So it's talking about labor flows. Suppose at the beginning of the year, employment E equals 2,000 in a small town with an adult, non-institutionalized population of 5,000. There are 1,500 individuals out of the labor force N. Over the course of the year, the following flows occur. So looking at this table and knowing how to read it is important. So the first row that says NU, that means that there's 200 people going from out of the labor force into unemployed. And then for NE, it would be out of the labor force into employed. EN would be employed into not in the labor force, and then so on. So what you have to do with these flows is calculate the unemployment and labor force participation rates at the beginning and end of the year, assuming there's no change in the size of the adult non-institutionalized population. So I think the most important thing to first look at is this beginning information, because understanding that is really going to be a vital part in getting these flows correct. So I'm going to bring up this whiteboard. So they tell us that the number of employed is 2,000, and then the population has 5,000. And then not in the labor force is going to be 1,500. So from what we know about unemployment equations already, we know that the labor force consists of employed and unemployed, and then population consists of those in the labor force and then those not in the labor force. So using this information, we can calculate the amount of people in the labor force. So we can take our population of 5,000, subtract 1,500 to tell us that there's 3,500 in the labor force. And then we can also figure out the amount of people unemployed from this information. So like I said, that the labor force consists of the employed and unemployed. So we can now take this new value for the labor force, subtract the employed, which is 2,000, to get the amount of people unemployed. And that is the two pieces of information you need to start off this problem that were not given. So now we can look at this table of flows. So I'm not going to rewrite the table of flows, but what I'm going to do is I think the easiest way to calculate each of these is to create your own table. And I'm going to make 3 columns saying employed, unemployed, and labor force. So looking at the first flow, 200 people are going from not in the labor force to employed. So so 2 things are being affected. 2 people are coming into the labor force. So that's going to add 200 to labor force. And then 200 people are also becoming unemployed. And then for the second one, it says going from not in the labor force from employed, and that's 300 people. So it's going to be another 300 added to labor force, but then 300 added to the employed column. The next one says they're going from employed to not in the labor force, and that's 150. So if they're leaving employed, that means 150 people are leaving the employed. And then if they're becoming not employed, not in the, if they're moving out of the labor force, that means 150 people are also leaving the labor force. The next one, 150 people are going from employed to unemployed. So 150 people are leaving employed, and we can add that 150 people into the unemployed column. Number 5, unemployed to not in the labor force. So 600 people are leaving unemployed, and those 600 people are also leaving the labor force. And then unemployed to employed, 600. So another 600 people are leaving the unemployed, but now they're going to employed. So this table I created really highlights just the direction of the flows and how it affects each category, I would say. So then what we can do is take the totals of each of these and apply it to our original information up at the top to then get these percentages of after the labor flows. We haven't done the beginning percentages, but I'll get to that. But I thought I should cover this table first. So then we just have to add all of these together. So the change in employed is going to be plus 600. The change in unemployed is going to be minus 850. And the change in the labor force is going to be minus 250. So what we're basically doing is using each of these individual flows to come up with the cumulative change in each category. So now that we have the information from before the flows and after the flows, we can look at these percentages they wanted us to calculate. So beforehand, the unemployment rate, we already know that's the number of unemployed over the number in the labor force. So we can easily plug that in as 1,500 unemployed over 3,500 in the labor force. So this percentage comes out to be 42.9%. And then for the labor force participation rate, we know that's the number of the labor force over the amount in the population. So then plugging in values for that, we can see that's 3,500 over 5,000. So that percentage comes out to be 70. And like I said, this was for before the labor flows. So we still have to calculate the unemployment rate and the labor force participation rate for after. So what we have to do is take each of our changes and apply it to the original information. So the new amount of, so I'll put after. The amount of employed is now going to be, originally it was 2,000, and now we're adding in 600 after these flows to give us a total of 2,600. For the unemployed, we originally had 1,500, and we're subtracting 850 from our flows, and that gives us a new amount of 650. And then the labor force changes, we originally had 3,500, and now we're subtracting 250. And that comes out to be 3,250. You also could have calculated that by just adding employed and unemployed. But I also just showed you how to use the changes from the flows. But anyway, now that we have this information, we can use it to construct the new rates. So the unemployment rate, we already have our equation up there. That's going to be 650 over 3,250, which equals 20%. And then the labor force participation rate is going to be 3,250 over 5,000, which comes out to be 65%. So this is all that was needed for number one. I think the most important part was finding the unknown information at the beginning and then using this table I created to organize how the flows worked out. And then we can just use the equations we've been learning or we've learned already to calculate the before and after unemployment rates and labor force participation rates. So that is all of number one, and moving on to number two. We can see this is slow reaction from the market. So in the small community of Highville, the aggregate labor supply curve is given by LS equals -50 plus 20W, and aggregate labor demand by labor demand equals 150 minus 5W, where W is the hourly wage rate. They give us labor supply and labor demand. Number one, of course, is calculate the equilibrium level of employment and wage, and what is the size of the labor force and unemployment rate in equilibrium. So they gave us labor supply as -50 plus 20W, and labor demand as 150 minus 5W. So, of course, knowing equilibrium, we can solve this as, knowing how equilibrium works already, we can just solve this equation by setting the two equal to each other. So, -50 plus 20W equals 150 minus 5W. So then adding 5W to both sides, we get 25W on the left. And adding 50 to both sides, we get 200 on the right. And then dividing by 25, we get an equilibrium wage of $8. And then as before, we can plug this back into either equation because we're in equilibrium, so labor supply equals labor demand. So I'm going to use the second one. So the equilibrium level of labor is 150 minus 5 times 8. So 150 minus 40 gets us to 110. So it asks for the equilibrium values, and then it says what is the size of the labor force and the unemployment rate. So when looking at these labor supply and labor demand equations, we can think of our labor supply equation as the labor force because it's the amount of people supplying their labor. So the total amount of people who are either unemployed or employed. So in this case, our labor force is going to equal 110 because that's what labor supply is after we set these two equal to each other. And then the unemployment rate, I think I've said this before, the unemployment rate at equilibrium is 0% because the amount of people being demanded by firms is the amount of people supplying their labor. So there's no excess of supply that causes some people to be unemployed. They perfectly match up with one another. So that's why we see that this unemployment rate is 0. So then it says, after a national story about the quality of life in Highville, the migration leads to an increase in the labor supply curve. The new aggregate labor supply curve is LS equals 20W. Calculate the new equilibrium wage. So we can just replace this from what we had. So 20W equals 150 minus 5W. So then adding 5W to both sides, we get 25W equals 150, and then dividing both sides by 25, we get a new equilibrium wage of $6. And then part 3 says, if the local labor market was slow to react to the new migrants, and as a result, the wage did not adjust to the new equilibrium wage, what would be the level of employment and unemployment, and what would be the size of the labor force? So this goes back to how we interpret our labor supply and labor demand equations. So if wages don't adjust, that means that with this new labor supply equation, we have to factor in a wage of $8 instead of $6. So labor supply equals 20 times 8, which we see is 160. And then we also know already that our labor demand equation isn't changing, so the wage of $8 in this labor demand equation still gives us 110. So as I said before, labor demand, think of it as the number of employed people because it's the amount of people firms are demanding. So knowing that we have the number of employed people and we have the number in the labor force, which is labor supply, we can then use these two to calculate the number of unemployed people. So 160 minus 110 equals 50. So again, labor supply can be thought of as the labor force, labor demand can be thought of as the number of employed, and we can take the difference of those two to find the amount of people unemployed. So they wanted the level of employment, the level of unemployment. And then they said what would be the size of the labor force, which we know is 160. And then you could find unemployment rate the exact way you've been doing if you wanted, which would be 50 over 160 multiplied by 100, and that gets us 31.25%. And that is all of number 2. Again, just more equilibrium, recognizing how the labor supply and labor demand equations fit into our idea of the labor force being made up of unemployed and employed. But I thought this one was pretty straightforward also. So I'm going to move on to number 3. So another example like we just did, consider the small community directly across the river from Highville called Lowville. The aggregate labor supply curve in Lowville is given by labor supply equals negative 20 plus 5W, and aggregate labor demand by labor demand equals 160 minus 5W, where W is the hourly wage rate. So calculate the equilibrium level of employment and wage. So again, labor supply equals negative 20 plus 5W. Labor demand equals 160 minus 5W. We can find equilibrium by setting them equal to each other. So negative 20 plus 5W equals 160 minus 5W. So adding 5W to both sides, we get 10W on the left, and then adding 20 to both sides, we get 180 on the right. Dividing by 10, we get an equilibrium wage of $18. Then plugging that back into either equation, I'm going to use the first one. We get an equilibrium level of labor as 5 times 18 minus 20, which gets us 70. So then for number 2, it says that same national story about the quality of life in small towns reported that the quality of life in Lowville is extremely poor. As a result, many of this town's residents decided to move, thereby shifting in the labor supply curve. So in the last example, the labor supply curve was shifting to the right, and now we see the labor supply curve shifting to the left. So the new aggregate labor supply curve is labor supply equals negative 40 plus 5W. Calculate the new equilibrium wage. So we can take this new labor supply equation of negative 40 plus 5W, and that equals 160 minus 5W. So then adding 40 to both sides, we get 200 on the right, and adding 5W to both sides, we get 10W on the left. Dividing by 10, we get an equilibrium wage of $20. And finally, the last part, it says, as in Highville, the local labor market is slow to react to the exodus of workers. As a result, wage does not adjust to the new equilibrium wage. What is the level of employment and unemployment, and what is the size of the labor force? So the same as last time, our labor demand equation isn't changing, so we can keep this wage, or we can use the original wage of $18 in this equation to still get a labor demand of 70. And then labor supply, we're now using that original wage of $18 in the new supply equation to get the amount of workers in the labor force at a wage of $18. So negative 40 plus 5 times 18 gets us to 50. So we can see that the level of employed is 70, and then the amount in the labor force is 50. So you should be thinking that this doesn't really make sense. How can you have the amount of people employed be greater than the amount of the labor force? So what's happening is there's a shortage. So if you were to think about it on a graph, where we have labor and wage, we had our two curves of demand and supply. We had this original wage, this original level of labor, and then our supply curve shifted in to get a new supply, but wages didn't adjust. So these 2 points I'm highlighting shows the amount in the labor force, which is 50, and then the amount demanded by firms. So this difference here is a shortage. So there isn't any unemployment because there's not an excess of supply, but it's going to be harder for firms because not as many people are supplying labor as they want people to. So again, there's no unemployment, but there is a shortage. In the last example, if you were thinking about it graphically, unemployment would be if there was a surplus of workers. So this difference above the equilibrium wage would be the amount of unemployed, because it'd be the difference of the people in the labor force and the amount firms demanded. But that's just thinking about it graphically. So that was all of number 3, though, so we can move on. So number 4, oh, I guess it's still equilibrium. Okay, so the labor market for textile workers in Texas is initially characterized by an aggregate labor supply curve of labor supply equals negative 20 plus 25W, and an aggregate labor demand of labor demand equals 400 minus 5W, where W is the hourly wage rate. So once again, calculate the equilibrium level of employment and wage. So this is number 4. So labor supply equals negative 20 plus 25W. Labor demand is 400 minus 5W. So of course, equilibrium, setting them equal to each other. So negative 20 plus 25W equals 400 minus 5W. So 30W on the left equals 420 on the right. So we get an equilibrium wage of $14. Plugging that back into either one, I'm going to use the second one. We get equilibrium level of labor of 400 minus 5 times 14. So that gets us 330. So then number 2, several factories decide to relocate to Mexico. As a result, the aggregate labor demand curve shifts in and is given by labor demand equals 220 minus 5W. Calculate the new equilibrium wage. Oh, that's it. So the difference in this problem is it's now affecting labor demand instead of labor supply. So the last two, I think, both dealt with labor supply. So now we're looking at it from a labor demand shift point of view. So the labor demand curve is changing to 220 minus 5W. So we just need to recalculate the equilibrium wage, which would be 220 minus 5W equals negative 20 plus 25W. So then adding 20 to both sides, we have 240 on the left. And then adding 5W to both sides, we have 30W on the right. And then dividing by 30, we see that the new equilibrium wage is $8. So then it says, if wages are inflexible downward in Texas due to fear of community outrage, calculate the level of employment and unemployment as well as the size of the labor force. So the labor demand, people in Texas don't want to push wages down, so we're going to keep this wage of $14. So we already know that the labor supply is going to be 330. And we have to recalculate labor demand, which is 220 minus 5 times 14, which we get as 150. So this is what I was saying in the last one. We can see now that labor supply is the labor force, and labor demand is the amount of employed. And in this case, the amount of people in the labor force is greater than the amount of people employed. So this is going to create a surplus, and that surplus is going to be the amount of unemployed. So by taking the difference of these two, we can find the amount of unemployed, which is 330 minus 150, which equals 180. And then again, you can find the unemployment rate if you wanted, which would be 180 over 330. But again, just identifying the labor force and unemployment and employment in these labor supply and demand equations. So the labor force is going to be 330. The amount of people employed is going to be 150. And the amount of unemployed is going to be 180. And then last it says, if the unemployed workers in Part 3 are unable to find work in a different industry due to lack of skills required by other industries located in Texas, what type of unemployment is this an example of? So this is strictly a conceptual question relying on definitions you've learned. So the answer for that is going to be structural. Structural unemployment is from that lack of skills. The other types are frictional and cyclical. So frictional is going to be a mismatch of jobs from like a job search, and then cyclical is going to be unemployment from recessions, like the cycle of recessions and expansions in an economy. And that is all of number 4. So we did a lot of equilibrium already. Hopefully you're pros at it, but we got a lot of practice with combining the two different ideas of labor supply and demand and then labor force. So hopefully you're able to follow along and get a really good hang of it. So then moving on to the last question, number 5. It's about unemployment insurance. So under a state's unemployment insurance policy, the benefits paid to eligible unemployed workers are determined by the formula B equals 25 plus 0.5 W, where B is the level of benefits and W is the former weekly wage. However, all unemployed workers are guaranteed a minimum benefit of $100 a week regardless of previous earnings, and no worker may collect more than $250 a week. So calculate the level of benefits and replacement rates for individuals earning $100 a week, $250 a week, and $500 a week prior to being laid off. So this one I'm going to kind of make a table again. So they gave us this equation of benefits equals 25 plus 0.5 W. And then they were guaranteed a minimum of $100 a week, but there was also a maximum of $250 a week. Okay, so this table, I'm just going to put the former weekly wage over here. And then the benefits. And then the replacement rate. So they gave us the first wage as $100. So to calculate their benefits, we just have to plug it in. So it's going to be 25 plus 0.5 W, which is 100. And that gives us 25 plus 50, which becomes 75. So according to this equation, their benefits would be $75, but they guaranteed a minimum of $100 a week. So the benefits for this person is actually $100. And then looking through our replacement rate, that's just going to be the level of benefits received over their previous wage. Hopefully you can read that. It's a little sloppy. I apologize. So anyway, this replacement rate for the first person is going to be $100 of benefits over $100 of their former wage. That becomes 1. The replacement rate is 1. So then moving on to the next person, they had a former weekly wage of $250. We do the same exact thing. 25 plus 0.5 times 250 to find their benefits, which in this case is going to be 150. Because half of 250 is 125, added to 25 gives us 150. None of that needs to be changed in any way to meet these requirements. That stays at 150. And then looking at the replacement rate, that's going to be $150 in benefits over $250 of the weekly wage formerly. And that gives us a replacement rate of 0.6. And then finally, for the last person of $500, to find their benefits, 25 plus 0.5 times 500. So that's going to be 25 plus 250, which is 275. But they capped it off at 250, so that's all this person is going to receive. Then we can find the replacement rate as 250 over 500, which equals 0.5. And that is their replacement rate. So this last problem was a lot different from what we've done already, but I thought it was pretty simple and just using the equation and then finding the replacement rate. So that is all for this week. Hopefully you are able to follow along, and good luck with your studying.